All right, we are ready for our next speaker. We have Kyle Shelton. He's an observability architect with Grafana Labs, specializing in AI and ML-powered observability, site reliability engineering, and DevOps at scale. He has experience running and optimizing global cloud platforms. He helps organizations gain deep insights into their distributed systems while reducing operational toil. He's going to talk to us today about building a center of excellence around observability. So Kyle?
Yeah. Y'all hear me? Mic check. We're loud? Loud and clear? Cool. All right. Thank you. We see the deck? We're good. All right. So my talk today is going to be about winning with observability. But first, before we get started, I want to settle a debate I've had in my family. Who here thinks that Charlie is the main character in the movie Charlie and the Chocolate Factory? Raise your hand. No, see, yeah. Who here thinks it's Willy Wonka? Yeah, all right, thank you. I just needed to settle that debate. I know Charlie is in the movie title, but in my opinion, Willy Wonka is the main character, and I was arguing with my wife about that, so I wanted to make it clear. A little bit about myself. Are we changing yet? No? A little bit about myself. I'm an observability architect at Grafana Labs. I help our largest customers build their observability strategy and help them gain business value from our platform. Before that, I've spent the majority of my career in SRE and DevOps. I actually got started pretty young. My dad was a telephone man for AT&T and got laid off in kindergarten and started his own cabling company. So I would tag along with him when I was like 10, 11 years old and jump into the places, whether it was an attic or a basement or something that he didn't want to go into, and help them pull cable. So I got started basically on layer one, but my experience went from as a network engineer at Verizon. From there I went to Splunk as an SRE. I spent some time at AWS as a TAM supporting the autos group, and my last actual technical role was at Toyota Racing Development, where I was a DevOps engineer helping the racing teams win races, and it was a really fun time. I like to connect around observability, DevOps, chaos engineering. I'm a big fan of breaking things to make them better, but also like racing simulation. I love the sim race. I love being at the racetrack. I can smoke a pretty mean brisket, and I'm also a high school basketball coach, and nowadays, bass fishing is a sport. I wish it was a sport back when I was in high school, because I would have skipped school a lot less. So yeah, please scan my QR code and connect with me. My blog's on there, on LinkedIn, and yeah, if you have any questions. But today, what we're gonna talk about, and when I talk to folks about observability, I always like to talk about culture and how it's important to understand the cultural shift and mindset that it takes to be successful with observability. So we're going to spend a little bit of time on that. I'm going to go through some areas that over my career, when focusing on, they have helped build that culture and build that center of excellence when it comes to observability, like speed, scale, migrations and modernizations or acquisitions. And then we'll get into an ideal state. I have a pretty sick pyramid with some memes that goes of the levels of observability you got to try to get to, so I'm excited about that. And then the last couple slides we'll talk about like how to build a people, process, and tools. So first, foremost, culture. I like to think about observability and telemetry signals as kind of like Legos. Like, anybody have kids? Who is the type of parent that just, when you get the Legos, you have just a big bucket with all the Legos, and you're like, here, kid, go play with Legos. Doesn't matter, make whatever you want. Versus the type of parent that has all the color-coded bins for each of the size of Legos. The reds are here, the blues are here. That's how I kind of look at telemetry data, right? And so when you have all these big data sets, whether it's logs, metrics, traces, profiles, are you just shoving them into a pile and searching and sifting through and wasting a lot of compute to find what you're looking for? Or are you putting them in an organized fashion using metadata strategy, tagging labels, whatever, and going in and only picking out what you need? Before you install any single agent or buy any tool, you have to understand how observability aligns with your business value objectives, right? Like, how is this tool going to de-risk your business? How is it going to lower your MTTX, detect, recovery, whatever? How is it going to lower your total cost ownership, right? Once you can build that path to speak to business and leadership, then you can build a foundation of how the tool is going to help you be successful. So, the first thing you're going to want to do is choose your why, right? I was talking about correlating value drivers to business outcomes. You have to be able to do this. Well, you can't just go to your leadership, or if you're a leader and asking for budget, you can't just go and say, hey, I need an observability tool to fix stuff, right? Like, you need to bring a plan together, say, okay, our MTTX is 2 days. We have to decrease that. We have to fix the problem and understand what the problems are before our customers do, because it's a risk to our business. So quantify those financial gains based on how you are putting the tool aligned with the value drivers. And then once you start doing that, you reduce your TCO and increase developer velocity, which is, in the DevOps world, that's one of the most important stats, right? Like your DORA metrics, how fast are you pushing out features? How fast are you building features for your customers? Or are your engineers just bailing water out of the belt and keeping things afloat? So, we talked about the why. Now let's discuss strategy. What are the cross-functional needs of each group that you deal with, right? Like your internal stakeholders, your operations, your security, your engineering, your developers. What are their needs? Security might have a lot more needs from a retention standpoint, or like just they need to see everything, versus your devs, like they only care about service X. Give them what they need to be successful, and then abstract everything else. You're also going to want to kind of like, I call it like a 40K assessment, right? Take the assessment of where you're at now. Don't try to start walking if you're barely even crawling, right? You got to iterate at a slow pace with these big data platforms, because if you don't and you miss something on day 1 or day 2, the day 10 problem that you have is bad, and it costs a lot more to fix, right? So think about that. And then the last but not least is you're going to want to look at your customers and identify your champions. And I'll talk a little bit more about that in a second, but find those champions that are going to support you in your movement and help to sell the tools that are part of what you're trying to do in your org. So, whenever I build something, I always got to figure out, like, what do I have? Or whenever let's say I'm a new SRE, I'm coming into a stack, or a new DevOps engineer, and I'm looking at the landscape, you have to take inventory of what you have. How many tools do you have? What groups are using what? What signals are you sending? What are you not sending? What are your metrics that are important to your leadership? You got to start with that. And then once you get to the next stage where you're looking at audit logs or billing, you're trying to figure out, right, what's going on and how much does it cost. So those 3 tiers have kind of been consistent in any situation when you're building a platform or an app or whatever. A big thing about this is aligning on how you're going to do this, right? Everybody has opinions, and in my experience, when you're working with software developers or other knowledge workers, the opinions can be very stringent, right, and very direct. So how do you work through that? How do you agree to disagree, right? One of the big leadership principles at Amazon was disagree and commit. How do you execute on that? So think about that when you're starting to have these conversations too. And then this is something that's kind of important to me. The difference between running open source at an enterprise level, you got to make the decisions more than just as the software is free, right? Because there's always a cost outside of a license. It's the cost of the engineering time that it takes to run it at an enterprise scale. It's the cost of the extra infrastructure you have to pay for on your cloud environment. And don't get me wrong, there are organizations that are really good at running open source software on an enterprise scale, but they also have very advanced teams and pay a lot of money for those in-demand engineers. So I like to think of it like this. It takes a lot of talent to run open source software at an enterprise scale, and it also takes a lot out of that talent to run software, open source software at an enterprise scale. And I can speak to, just with my experience of being told, hey, I want this paid platform. I want to abstract all the management of it. And they're like, no, you need to use the open source version and make it work. So, last but not least, what does the culture of observability look like? Well, you're going to need to kind of talk about the shifts. Like if you're not building a developer portal, or you're not kind of increasing your developer velocity, how are you going to present that to your users? How are you going to make sure that all of the teams are aligned on this is the mission, this is how we're going to do this. We're not just going to throw everything in a pile. We're going to come up with a strategical plan on how we align our metadata, and then we're only going to put in the paid platform what we need, and store the rest in object storage or whatever if you need for compliance. But we're only going to search for what we need, right? Like that just-in-time mindset, from I guess the Toyota way, right? So take that mindset when you're thinking about your telemetry data. And then after you start get going, let's say you've brought an observability tool into your stack, and you solved some problems, your alert fatigue is going down for your SREs, and you're starting to be more proactive. Showcase those to your internal group. Showcase those wins that your group is having. We at Grafana, we do what's called Grafana Days, and one of the key things about our Grafana Days is that we normally have an internal group talk about the problems they solve with Grafana, right? And so do that with your tools, and get your stewards excited about what they can do. Because once you start seeing the value and you start seeing the effects of having happier engineers because they're not getting paged every night at 2 a.m. and the apps are working, they get to work on the strategic. That's another thing to think about is when everything's breaking, your really smart engineers can't work on the cool stuff. They got to work on just bailing water out the boat. So do things like that to encourage adoption. And then if you're one of my customers, you'll hear me say it all the time, like metadata alignment, tagging structure, label practice, label strategy. You have to have how you're going to organize your data. You have to have that strategy tight. You have to be able to break things down at whatever level fits your business. It all depends. I can't just say, yeah, use service name or use namespace or use this or that. It all just depends on your stack, but it starts and ends with that metadata alignment. And if you don't get that right, your day 10 problems are going to suck. Point blank. When you're working off SLOs and error budgets and you're having those data-driven discussions between your product owners and your developers, that's a smooth running machine, right? Like there is no ambiguity about what's going on. Your service A is sucking butt and they're not doing very good. You can see they're over their error budget. Well, let's go fix it and let's go see what's going on. You can focus your SRE team on that. So also kind of look at your anomaly detection and predictive analytics in these tools. There's a lot of really cool AI features in the tools now. Leverage those. It's really helpful. And big thing, this is DevOps crowd, so y'all are going to be pretty happy about this too. But everything is as code, right? Everything's in a repo. If it wasn't in a repo, it doesn't count. It doesn't exist. Have that infrastructure as code mindset, the GitOps mindset. When you're building these systems, it makes it easier for onboarding, and it just makes your life easier. DevOps, right? Woo. Cool. And then last but not least is pretty important too. Incident management. One of my favorite courses when I was an SRE was by these guys that run the basic paramedics for Burning Man. So I'm not sure if you're familiar with Burning Man, but it's a big festival out in the desert. They don't have any support, so it's a big city for a week, and they have a lot of ex-firefighters and military personnel do that. Well, this company goes in and teaches you how to manage incidents like firefighters and first responders do. And when you take, if you think about it, firefighters, cops, military personnel, they're really good at dealing with incidents. That's like literally their job. So the system that they use is very efficient, and they came out and they taught us how to do that. And from then on, I kind of took a different approach to incidents, and like having an incident commander drive the resolution is very important. So build an incident response program into the heart of your culture, and that'll contribute to success. All right, so we talked about culture. Now let's get into the fun stuff. I'm gonna start with speed. Developer velocity, speed. I like to go fast. If you ain't first, you're last. So my goal when I was a DevOps engineer was to make sure all of my developers built their stuff fast, right? Like it was at Toyota Racing, speed was kind of in the heart of our culture. We're literally like working at the racetrack and trying to win races. So number one priority was speed. But you know, in other places, the slower we were at delivering features, the slower we were at detecting errors, the like more miserable of a place it was to work from a tech perspective, because there was no innovation. So what does like a bad state look like? Slow release schedule, long MTTX, high total cost of ownership, and unhappy engineers, right? And this is, you're gonna see a few AI arts. I use this bullet list to generate that, so I think the AI art's getting pretty good, but you know, that's kind of how you feel when it's slow and things are just not going great. What you want to get to, though, is that really happy state, right? You know, the fast releases, the more features, like when you're an engineer and you're just knocking stuff out, jumping with ribbons and stuff, it's fun, right? But that's like, from a speed perspective, you want to focus your efforts on improving speed, whether that's in your CI/CD pipelines, feature requests coming in from your customers, whatever. Fast, 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 move fast. Now, don't go reckless. There is a thing of doing harm when you're reckless and you don't have your necessary like checksums in place in your pipelines and everything. But you know, if you're talking to me, I'm going to be pretty fast. All right. So here's a picture, a few pictures I've taken at the racetrack. There's a video if you could play that. But I want to tell a story about one of my first months. We did a test in February out at Coda, and in February, and then went out to the race with Tyler Reddick, and yeah, go ahead and play it. And this is what we got to do once we honed in all our data and focused on speed. We got to celebrate in victory lane. I don't know if it's going to play or not, but it's just basically him burning out and me screaming, yeah! So if we could play that, that'd be cool. If not, I'll just move on. Is it going? There we go. Yeah. So this was my favorite work trip, by the way. And this is what we got to watch after we were done. So pretty cool. And crazy thing about this was his cool suit wasn't working, so he was basically on the brink of a stroke for about the last 10 or 15 laps. If you don't know, race cars don't have air conditioners. It's really hot in the inside. So they have what's called these cool suits that run cold water through them, and it keeps their body temperature cold. Well, that was broken, so it was running actually hot water through him. And you can kind of see it when he jumps out. But if you want to get back to the deck, and yeah, I was pretty happy, as you can tell. Yeah. So when you focus on speed, that's what happens, right? All right, yeah, go ahead and go to scale, which is, keep on going down, 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 4 more, yeah, right there. Sweet, thank you. Scale, now, scale is really important when you have larger distributed systems. Sometimes there are a lot of things that when they break, other things break, right? And you have to think about like, okay, what if you're at your limits and how do you scale out? Are you building, you know, are you done with this data center if you're on-prem, cloud? Scale is a problem that most big enterprises have. And so when you're dealing with these problems, right, you have that high complexity. Now there's a difference between complication and complexity. If you haven't ever researched about that, your goal needs to be to reduce the complexity, because complication is going to be there no matter what, especially as you evolve, as you build more features, as the maturity of your systems grow. what you don't want to do is add unnecessary complexity to those systems. So a system that doesn't scale very well is normally pretty complex for no reason, right? Over-engineered, you've seen that a lot. Inconsistent environments. How many people have their dev and staging environment match exactly to prod? Not a lot, probably. I mean, it's expensive, but they don't know what happens when they deploy because their dev environments don't look the same as what they're doing to their customers. So that's something that, if you can, I know there's cost reasons a lot of the times for that, but if you can, try to mimic your deployment patterns and how things are based on your dev environment that is going in prod, so that you remove the unknown. And then high toil. If you're an SRE DevOps engineer, your job is pretty much to remove toil. We talked about that a lot at Toyota. We called it Muda, but it's constant, removing that waste, removing the toil, finding things to where you can clean them up and make them better and make them faster. Your life will get easier. And then when we're in a good platform engineering mature state, right, we're managing our systems through SLOs. There's clear data behind everything. You have error budgets, and you're kind of low on the toil Muda side. You make data-driven decisions. So that's scale. Now, migrations, modernizations, and acquisitions. This is something that when you're dealing with a new startup or whatever. I was working for a telecom startup and we got bought. It's actually how I got into cloud because I was a network engineer working at 2 data centers. Our company got bought. They're like, you need to learn AWS or find a new job. And so that's when I was like, all right, I'm going to be an SRE DevOps now, even though I spent most of my career in network engineering. And with that came a lot of mistakes when it came to cloud migrations. Here's lifted and shifted a big SQL database, paid for the license in AWS and the most expensive instance size. I've done that. Not smart, but we did it because we were just urgent, right? We just had to get things moved over. The cost got out of control. We ended up having to redo some things, but when you have those migrations and you're rushed based on an acquisition, you have a team over here that's doing things one way and your team that's doing it another. How do you come together and how do you figure out how to do it, right? It's something that is very difficult. Or even internally, whether switching to Graviton. I remember the Graviton migration. I don't know if you've done any of those on the AWS side, but that took us 8 months to migrate 15,000 EC2s. And there's a lot of problems had we not had proper observability that would have been bad, right? It would have been painful for the customer. It would have cost us a lot of money. But we made it a point to build an observability strategy, putting side A, side B, track okay, track is everything good, track the switchover, track all the network traffic, validate, and continue to move forward. So this one was pretty cool. I put it in a prompt and said, have the Windows guys and the Linux guys get together. I don't know if this really happens in real life, but they're all happy, and we got the dashboards in the background, and you got that knowledge transfer, and you're collaborating. Everybody's happy. We're talking by the cooler. So we've talked about those 3 tiers. Now let's get into the ideal state. I got to move it forward, but troubleshooting as a whole is really hard. Most of y'all have been paged. Most of y'all have been woken up at night, and your first thing you got to do is oh dang, what's going on? I don't know where I am right now, but I know I have to get on this bridge and talk to this executive and tell them, yes, sir, I got this, or yes, ma'am, I'm going to fix it now, and you don't know where to start, right? There's limited correlations. You got these failures that start cascading everywhere, right? That's no fun. I don't know if y'all remember that AWS December 7th outage with the network thing, but yeah, that was not a great day. And you also have noise, alert fidelity. That's something that I've seen a lot with my customers where they got 15,000 alerts, but they're only actioning 4 or 5, right? So how do you create a system? And what they did is they created an alert quality dashboard, and they put a scoreboard out with all their service owners, and it was like, hey, guys, your alerts, you're not even using them, you just create them for nothing, and your P2s are automatically getting audit closed. What are you doing, right? Put a scoreboard out there. That has worked in the past. when I put the responsibility out on the teams, and nobody wants to be in the yellows or reds when it comes to those things. But when you're onboarding, your observability has to answer 4 things. What happened? When did it happen? Where did it happen? And why did it happen? And if you can do that without a lot of prior knowledge to your system, you're going to be in a good spot. And I'll tell you why. Because as you know, SREs, DevOps engineers, we're a hot commodity, so we're moving around, right? So you go from one stack to another. If you can do these things out of the box as soon as you get onboarded into that service or that team, you're going to not have to go through what that like tribal knowledge, or I think they were talking about, Pam was talking about that engineer who knows everything but doesn't like to share his knowledge, right? Likes to put himself in a corner and be the hero, right? What's that in the Phoenix Project? Brad, I think it was his name. Yeah, don't be a Brad. If you can answer these 4 questions without having a lot of prior knowledge, then you're in a good spot. And so let's visualize this from a meme perspective, okay? Reactive. This is fine, I think we've all been in this state, just like whatever. When you get to the proactive, where you're like, all right, I see that fire coming, I'm gonna spray it with the water hose, I got this. Our predictive analytics, right? We need more cowbell and predictive analytics, and then we've all gotten in that self-driving Uber in the driver's seat, and they're looking back like, yeah, autonomous, right? ADAS, 5, all that. But this is kind of the levels of observability from a like how you operate, sort of. 2 minutes? Okay, cool. So last slides. I do want to say a warning: when you're building a center of excellence, everything's different. This is not an exact science. Don't just like try to take a one-size-fits-all approach into this. Look at what you have. Be able to assess where you're at and how you got to get there. But it's not just, you don't just wake up and build a center of excellence overnight. It takes a lot of time. It takes a lot of buy-in. What does a center of excellence look like? It's a team that provides leadership, best practices, support, training, and enablement. So what is a COE? People, process, tools. Starts with the people first, right? If you don't have the people, the process and the tools are not going to work. If you don't have the process, the people and the tools are not going to work. If you don't have the tools, then the people and the process have nothing to do. So remember that. Here's another formal COE definition. And then if you're trying to build it, this is kind of like a Gantt chart of how to build it out. You build your COE blueprint, you have a design workshop, you get all your champs together, and then you assign roles, and then start with the people process systems, and then go from there. And then why is it needed? Because you need to lower TCO and increase your ROI. So we move through that. Last thing I want to leave you with, in our State of Observability report last year, and those organizations that have the centralized observability, almost 80% of them save time and money. So it is a good investment in your business. If you're on the fence about it, I highly recommend it. And thank you for your time.